Right. Hi, my name is Moritz Mueller. I work for SIDN, which is the registry of the Dutch TLD. We have roughly 5.6 million domain names, of which half of them are signed with DNSKEY, which makes us very proud. And I want to talk about the Root Canary Project, where we want to measure the, as you've probably heard of, the postponed rollover, the Root KSK. SIDN is not the only partner at this project. We also have a bunch of universities in the US, in the Netherlands. I'm also a PhD student at the University of Twente, and we stay in close contact with the people from ICANN to share any insights that we gain. The Root Canary Project got its name from the canary in the coal mine, and it has the goal to basically track the operational impact of the Root KSK rollover and should act as this bird in this small cage as a warning sign in case validating resolvers fail. So we have a resolver-centric perspective. We want to measure the validation during the whole KSK rollover process, and we want to learn from this event so that this planned KSK rollover won't be the last one. First, a few words about the methodology. We have basically 4 different perspectives. We have an online perspective and an offline perspective. The online perspective consists out of measurements with RIPE Atlas. The folks at RIPE implemented our measurements in all the RIPE Atlas probes, which are roughly 9,000, 10,000 RIPE Atlas probes, and they carry out our measurements roughly every hour. We use the Luminati HTTP proxy network, which is an interesting way because there we can send HTTP requests through the users of this HTTP proxy network. And these HTTP requests then trigger a DNS query, which again allows us to check whether a resolver does validation or not. We want to use APNIC DNSSEC measurements as validating later on. And we also have an offline perspective, which is the data from the root servers, which is provided from the root servers for certain key dates of the rollover, not only to us, but to any researcher, basically. With RIPE Atlas and Luminati, we cover roughly 14,000, 15,000 ASs, but we want to have more, and this is why later in this talk I also want to invite you as operators to contribute to our measurements. In our measurement, we basically have signed and bogus records for all the DNSSEC algorithms and for most of the DS algorithms. And from the RIPE Atlas probes and from the Luminati clients, we probe all these these records roughly every hour. For Luminati, it's a bit less. And this basically gives us 3 different outcomes. One is a resolver validates correctly. Another one is a resolver fails to validate. That can be a serve fail, but that can be also another error. We see if resolvers just don't validate at all, and we have a couple of other corner cases that we are probably not covered by the first 3 options. The measurements also allow us to measure some other things like adoption of DNSSEC algorithms. We try to do some fingerprinting with this data, but in this talk I mainly want to focus on the actually KSK rollover. This measurement gives us a snapshot of resolvers, but also allows us to measure resolver behavior over time. And this is what we did in September when the DNSKEY resource record of the root zone suddenly became 1414 bytes. And that might have caused troubles with IPv6 fragmentation, as Jeff Houston also explained yesterday already. So this is basically what you see on this slide. And the vertical line, the vertical green line, shows the time in which the new ZSK was in the zone. So from that time on, the DNSKEY resource record suddenly became 1414 bytes big. And you would have expected an increase in number of serve fails over time as soon as this resource record has this size. But what we have observed from RIPE Atlas probes is that nothing like that happened and everything stayed quite stable, which is a pretty good sign. I've mentioned that RIPE Atlas has like 9,000, 10,000 probes, so it's quite a limited data set, so we also looked at the root servers. And in this case, we looked at Beirut, and particularly at the site of Miami, just to decrease the number of data that we had to crunch. And again, here we see in the vertical line the time when the new ZSK was in the zone, and we see how many replies in DNS were sent via TCP or via UDP. And if the size would have been too big for many resolvers. You would have expected an increase in TCP connections as well. The blue line shows the ratio between UDP and TCP connections, and then again, it stays rather stable over time. The folks at ICANN looked a bit more into the root data for a longer period of time, because here we covered just a couple of hours, and it stayed basically like that. So again, there was no big difference. The same goes for DNS responses that the TC bit set. It also stayed quite stable. So overall, the increase of the DNS key size was not a big issue during the rollover, and I think most of the people expected that. But we still have the actual rollover to come, and the folks at ICANN were not sure what this might actually cause. So we now have a couple of vantage points for our measurements from Luminati, from RIPE Atlas probes, but we would like also to invite more operators to contribute to your measurements, especially if you don't have a RIPE Atlas probe in your network, or you're running a RIPE Atlas probe in your network in a labs environment. We provide now a shell script, which I hacked together yesterday, which does queries to our 72 test domains and then reports the information back to our servers. You can find the code down there. It's quite transparent also about the data that it sends back, so it won't steal any data from your networks, I promise. And yeah, you can check it out there. We also have a couple of other information from our project. We show how the state of validation actually is from our vantage points. We have a live map that shows the measurements of RIPE Atlas probes, so we can see if resolvers of RIPE Atlas probes fail in real time. So on the actual day of the rollover, you might then see suddenly red dots popping up everywhere. We hope not, but that might actually at least look cool. Again, there's a link to the shell script, and if you have any questions or comments, then please feel free to contact me. That's it. Thank you.
We'll take questions.
Jeff Houston, this will be hopefully quick. I said I wouldn't ask you questions, but you know, what the hell. In the DNS, most folk actually wouldn't have a clue what resolvers they use. And when you start talking about forwarders and chaining of queries, everyone's eyes glaze over and they sort of turn asleep, like you guys are, because it's hideously complicated. And the real question for most users is actually simple. When you guys roll the key, is my DNS going to die? How can you make this work answer that query of mine? How good is my DNS service? Not yours, mine. And is it tracking this key roll correctly?
Yeah.
What would you need to do that for me? What script? What's necessary to make a canary that works for me, the end user?
I think, yeah, you could definitely provide the same script. You can run it at home. That would be one option. But then again, you would just see if things fail. You would not be sure if the resolver you're using has the new key already. So, of course, that's limited. But I think you have an idea yourself.
But I use 3 resolvers because I've got 3 entries in my etcresolve.conf. And I don't know which one's being asked.
Yeah.
You know, my question's more subtle than how does that resolver work. It's, as a user, don't teach me how the DNS works because, you know, I've only got a finite lifetime. Tell me if I'm going to die.
Yeah. As I've said, we have a resolver-centric measurement in this case, so we can't actually, we just can estimate how it might look like at the user. But yeah, for the measurement that we're having right now, we can't tell you that.
But
right.
Your next measurement
we have
will
to
be
think
more
about
user-centric, right?
Yeah.
Cool, thank you.
Okay, thank you.
Thank you, Matthew.